Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 5.3, Sequence versus Series. In a nutshell, a sequence is a string of numbers which might or might not be related. So I can just randomly shout 1, 3, 8, 12, 15, and that is a sequence. But this sequence doesn't, the only relation in this sequence is that every subsequent number is larger than the previous one. So it's technically still a sequence of numbers, but most other sequences that you'll come across have a particular relationship between numbers, such as n to the power 2 would give you from 1, 1, 4, 9, 16, 25, etc. Those will be sequences. A series would be the sum of a sequence. You have came across series before when we did in proving by induction in chapter 1, and turns out that you do need to know the sum of the series r squared and r cubed off by heart, or it might be in your equation booklet actually. So technically you do not need to know it off by heart, but it's nice to know, I guess. And you are asked to prove them by induction, which you have already known how to do so. So I'm gonna give you a refresher on sum of r squared and r cubed. Then I'm gonna talk about how to do a series sum by differences. Let's have a look at the sum of r first of all. So the sum of r, wait a second. Okay, so the sum of r is just from 1 to n is n times n plus 1 all over 2. And this one you can prove by induction, or you can. This is fairly obvious because when you sum all natural numbers from 1 to a certain value, you can just add up the pairs of the first and the last term, and that will be half the number of those pairs, which gives you the sum of everything. So it's kind of, I guess it's not that obvious, but it's easily workable. Then we have sum from 1 to n of r squared. This one not very obvious at all. We have n times n plus 1 times 2n plus 1 all over 3, actually 6, I think. Yeah, so this is, we have proven this by induction before, and we have n from 1 r cubed equals 2. This one is less obvious, n squared times n plus 1 all squared on 4. So yeah, these are the three general series that you do need to know, which it's all provable by induction, so I don't think you need to worry about them too much. There's a new method called summing by differences, which I'm going to talk through right now. Okay, so now sum of differences. This one is a lot more interesting in comparison to just straight summing r squared and r cubed. So we have normally a two sets of values that are subtracting from each other, which is sort of confusing at the start because no matter how you look at it, it doesn't look like this is gonna give you a nice thing. But let's try to expand the first few terms. So for n equals to just 1, we have 1 on 1 take 1 on 2. For n equals to 2, we have 1 on 2 take 1 on 3. For n equals to 3, we have 1 on 3 take 1 on 4, etc. And for n equals to n, we have 1 on n take 1 on n plus 1. With that information sorted, we can look at the pattern derived. Note that I have shifted everything by 1. This is because if you look carefully, this set, if you add them together, goes to 0. Same for this set. Same for this set. And eventually everything in the middle just goes away and leave you with the first term, 1. So 1 take 1 on n plus 1. That would be the answer. And depends on what the value of n is. If I say sum the first 100 terms, then we have 1 take 1 on 101 as your solution. And of course you have 100 on 101 as your final result. But that is not the main issue right here. And there are also times that if n is infinite, find what this value tends to be. So if n tends to be infinite, so that would result in 1 take 1 on infinity, which is 0. So 1 take 0 gives you a approached value of 1. So this tends to 1 when n tends to infinity. This works for a lot of cases, especially for cases when you need to do partial fractions. At this stage of A level, I'm pretty sure they would ask you to do first of all part A, which is to partial fraction a certain massive fraction expression, and then you will be asked to do the sum of differences. They might not tell you to do the sum of differences, they might just say sum the first so and so number of terms, but then after you have done the partial expression, you should be able to just look at it and find, oh, there are negative signs, and so there might be something that we can cancel out. Note that there are times when there are 3 terms, and you will just have to kind of look at it and try to investigate and see if it can cancel. Yeah, so I'm gonna give you some questions in a bit to practice on. As to how the exam questions are gonna ask you, of course they aren't gonna tell you to sum a series of just r squared. That would be just giving marks away. What they would normally do is to give you an expression such as, let's see, r squared take r plus 3 or something like that, and you need to sum that to n. Then for these kind of things, you can always break the summation into the 3 components and sum them up. And when you have a summation of 2r cubed or something, or just basically kr, you can take this 2 out, and so you have 2 lots of the summation of r cubed as your result. So make sure you can break open the expression into different sums such that you can just do a standard expression. The aim of this whole thing is to find in algebra form the powers. So for this one, you'll have 1 lot of r squared sums, take 1 lot of r sums, add 3 lots of sums, and for integers, you just sum n lots of 3 is just 3n, so that's kind of obvious. For the sum of differences, however, make sure you know how to do partial fractions. It's very important, and once again, I'm pretty sure they will not just tell you to sum a particular fraction without telling you to do partial fractions beforehand. But of course, if you're very stuck as to what to do with it, then do use partial fractions. And again, partial fractions might be used in differentiations or integrations as well, so it's a very useful skill to have. So for questions, I want you to evaluate these 2 expressions. So the 2 types of sums that you need to do or need to be able to do. And as usual, I'll give you 5 seconds to pause and carry out the calculations. And I will show you the answer in 5, 4, 3, 2, 1. And the answer is shown right here. For the second one, make sure you do the partial fractions. First one is relatively straightforward. Just make sure you don't do any algebraic errors. And yeah, if you have any questions with these sums, then leave it in the comment section below. But for now, thanks for watching, and I will see you on my next one.